Hello, this is Dan Seal,
and Peter Stromhog.
and we worked on a network science project here at Wetzel High School with the assistance of Binghamton University. We studied virtual economies, specifically the one in the game Team Fortress 2. In the game, players can receive items, buy items, convert one or several items to another item using predefined formulas, and trade these items with other players. We focus both on the network surrounding the creation and modification of the items, known as crafting, and we refer to this network as the static network, and the network in which players barter in order to obtain better or at least more preferable items. We refer to this network as the active network. The crafting or static network is created by looking at the various reactions that allow the player to convert items from one form to another.
Whereas in a chemical system, you can use two hydrogens and an oxygen to create water, in a crafting system, you can combine three items, known as refined metal, to receive a cosmetic item known as a hat. This network is a bipartite graph, where nodes are connected by their placement in reactions. In the active network, players can publicly make offers for items and initiate trades with other players. An example of a trade would be one player posting an offer saying, "I have 3 refined metal and 1 reclaimed metal. Would anyone like this for a strange hat?" There are many of these offers and trades every day, and estimations of the value of this combined economy range from $25 million US to $50 million. The network is also a bipartite graph where the items that are offered are connected. It was very interesting and informative to work in the NetSci program. Thank you to everyone who organized this.
So we finally entered all the data into Excel, scrubbed it, and opened it up into Aura, and the first thing we saw was a big giant hairball. We also asked students questions to get information about them, such as their gender, grade level, which campus they attend. After making the survey, we distributed it to both campuses at New Brookford Academy. Then we began to open the networks in Aura, and we visualized it first. So after we first opened up the network, in Aura, we realized we had a big hairball and we didn't really know what to look at. So from there we started opening up the network and really looking at the little centrality measures that we have.
Well, okay, so NetSci, I didn't know about it either until last summer, actually, when I was recommended to join this program. And I thought, well, okay, cool. We get to go to Boston, we get to meet new people, and we even get a stipend from it. Oh my goodness, I need to start this immediately. So I signed up and I went as a representative from NFA, and I absolutely loved the experience. NetSci is a program where kids and students like myself, we can really expand our horizons and learn more about networks. And I know you may think, oh, well, what's so special about networks? Well, actually, networks are present everywhere, ubiquitously. And it's just, I didn't even know that there were so many networks that I could see on a daily basis until I joined the NetSci program. I think that it's a good opportunity, if anything, for students who want to go into research or really learn about what the real world is like, because you will make mistakes and you learn how to solve problems, and I think that is one of the most valuable characteristics or traits or skills you can learn as a student trying to grow up.
Being in the program for about a year, what have you learned so far?
Well, I've learned how network science applies to a lot of things that I never have seen it applied to before, and I also learned a little bit about programming from using Python and Aura.
Threw it out the window. Lately you've been dead, suspicious for the winter. Legs like little splinters.
Connected these campuses really are. If it's 2 campuses and 1 school, or if it's just 2 campuses on their own. And we were looking at the communication that goes on between the two campuses and how they're correlated. Well, I've been interested in computer programming, and all the programs that we have learned, I've learned into more depth, and they're really, really interesting. You'd be surprised at how much network science plays a role in your daily life, and learning more about that. I hadn't known much about it, and so learning about it really opened up my eyes to things I didn't know about.
Not only do you meet a bunch of scientists and and go to many different places like West Point and Boston. But you also get to get a good benefit out of it, like learning something that not a lot of people get to learn about.
It comes down to if you're still talking to people at the other campus on a personal level or for extracurricular activities. So that's the networks are mainly looking at.
Definitely narrowed down the decision of what I want to do, but as far as declaring a major yet, I have not decided. Like, I know I want to do possibly in the engineering, since networking can apply to it with like the cells and of organisms and human life. The process that I learned is prize patience. There's a lot to learn. You have to, like Ms. Lori said, get to know your data or else you can't find the story. But the research process has been interesting and it'll help me for college.
Hi, I'm Jacob, and this is my project for NetSci. I created a tool which can help visualize algorithms in the context of a maze, and I call it the Maze Algorithm Viewer. Dijkstra's is a very inefficient algorithm which simply searches out the entire grid area before eventually finding the end, and you can move the start so that you can see the way in which it spirals outwards. A star, on the other hand, goes directly towards the end in a very linear fashion. And this is caused by what's called a heuristic. Basically, it calculates each square that it visits, the distance from the end, and chooses the next square based on that. And so my hope for this project is simply to implement more algorithms, keep it interactive, and teach people more about network science.
Alright, hi, my name is Dennis, and these are the two projects that I've done for NetSci High. On the right here we have Blaze, and the idea of Blaze is that you have a forest fire burning, and what happens is that you have to stop it before it gets to the end. And the idea is you only have a limited amount of water, and depending on your difficulty level of easy, medium, hard, expert, custom, you choose how many squares you get, how much time, and the percentage of the forest burned is what determines your final achievement level.
So I'm Zach Belech, and I worked on a game called Blaze, where you have a network of trees, and then you have fire that percolates through the network, and the fire can spread to like any of the adjacent places. It starts all the way on one side, and you can go to any of the places that it's next to on the end that aren't burned, and it only spreads to trees, obviously not to dirt. And the fire, you try to stop it with water, and you try to save as many trees from getting burned. And then the trees go from green trees, and then they get on fire, and then after a certain time of being on fire, they burn up and turn into ashes. And the water can't get burned, obviously. And when you click on the water, if you click on a square that already has water, it expands to all the squares around it. So they have water, so there's like a pool of water, and it flood fills around from that one section of water. So you can just click on the same square to fill in a big area.
Lights like little splinters.
Okay. All right. Can you tell us about the methods that you used to answer your question? Sorry. Let me phrase it another way.
So awkward on camera.
You're not recording that, are you?
Yeah, I did.
Oh my god.
Answer like 5 questions.
I know, but whatever.